first slide. I can reach it. Yeah. There are some problems. No. The very first. Me and colleague of mine, Violeta Dimitrova, are working on the project named Structure and Ecological Functions of Dead Biomass in Beech Forests, Fagus sylvatica in Western Bulgaria. I'm going to present the results from both papers we prepared for this conference. Maybe you know, but the dead plant biomass, many biologists and ecological researchers know that it plays an important role in the functioning and productivity of forest ecosystems through its influence on biodiversity, carbon dioxide storage, substance and energy cycling, soil protection and tree species regeneration. It provides important habitats for invertebrate species and small vertebrates. The litterfall, that is all that leaves, branches, seeds, barks, which is on the soil surface in the forest, are a part of this dead biomass. It affects generation, soil moisture, fertility, compositions of soil, fauna and flora. With a large part of the chemical elements are returned back to the cycle of the ecosystem. It is an essential carbon depot, as I mentioned before. Based on the amount of different fractions, conclusions are made about the influence of climate and phenotypes of tree species. Litterfall is also included as a component of forest monitoring. Nowadays, questions related to the rate of decomposition, the organisms involved in this process, as well as the dynamic of elements, are discussed. The aim of the present study is to evaluate the role of litterfall as a depot of chemical elements. The object of investigations were common beech communities in western part of Bulgaria. This, I'm not sure how to show you, maybe this way. This is Stara Planina and this is the Vitusha mountain. We have two sampling plots on each of these mountains. Bulgaria was covered about a forest in Bulgaria have about 41% of cover, and in western part of Bulgaria the main tree species is this Fagus sylvatica or common beech. Climate was temperate, continental and mountains. On that table you can see altitude. The both assembly plots on Vitusha mountain are about 1000 meters altitude, and for Stara Planina we choose one highland and one lowland stand. Beech stands on Stara Planina are a little bit older than these on Vitusha mountains. Methods that we used, especially for chemical analysis, were several. It depends on the element determined. We used average sample from 3 collectors, such like this. On the photo, for each site, biomass were made to powder size using grinding mill. Main components such carbon, nitrogen and hydrogen was determined by automatical element analyzer. Phosphorus was measured spectroscopically after turning to blue complex. Metals were determined after dry digestion first, and consequence atomic absorption spectrometry of solution. moisture were measured by moisture measuring balance, and to estimate mineral quantities, we multiplied the concentration of every element and amount of that biomass for each fraction. On that table, you can see the amounts of elements for both Vitusha and this third and fourth columns mountain, Staroplonina mountain. We found that average amount of elements varies between 582 grams per kilograms to 607 grams per kilograms. Sum of macroelements, it's written here, significantly exceeds the amount of microelement in both mountains. From macroelements, carbon was predominant with 463 grams per kilogram, and for microelements, magnesium was predominant. Trace elements are in the following sequence: manganese, followed by magnesium, followed by manganese, iron, zinc, lead, and copper. No significant difference in the amount of elements were observed between two sample plots in both mountains. When compared the average result from two mountains, it can be seen that the lead is more in sample areas in Vitusha, especially these that are close to the road. Percentage ratio of all elements were presented on this figure and were found to be similar. The predominant elements here, carbon about 80%, followed by hydrogen about 13%, nitrogen 3%, and calcium only 1%. Remaining elements are presented in very small amounts, less than 1%. When calculated annual stocks of elements, we found that in Staroplonina there are 1,569 kg per hectare annual stock, and for Vitusha mountain almost half of that amount, 960 kg per hectare. Comparison of our results for annual sums of elements are close to the other authors that cited. As a conclusion, we found that average annual reserves of the elements that return to the beech forest ecosystems are about 1,465 kilograms per hectare, of which macroelements are 1,558 almost kilograms per hectare, and for microelements about 7 kilograms per hectare. I just said about the percentage of main components. The remaining elements are presented in small amounts, less than 1%, and the order of microelements are magnesium, manganese, iron, zinc, lead, copper. And we can conclude finally that as a result of conducted research, the leaf litter represents a significant depot of elements, which the largest percentage was carbon. Second paper that we prepare is chemical composition and stocks of nutrients in dead wood of beech. That means another fraction of dead plant biomass. That's why I'll present you only results, because the objects, situation, and all other characteristics, also methods, for determination were the same. We found that the main structural element of dead wood, such as living wood, is an organic carbon, and for those sampling plots, and its content varied widely between 47 and 70%. The highest amount of carbon was determined for standing dead wood, comparing to the other fraction, except for the sampling plot 1 in Vitusha mountain, where we found that the highest content of carbon was found in stumps. The next element in content was hydrogen. Its amounts vary between 7.7 and 10.8%. There is no clear trend in which fraction the hydrogen content was dominant. And all results are presented in the following 4 tables. I only want to pay attention that for nitrogen, here in the second column, we found that in stumps its amount is higher because they were in a higher degree of decomposition. On that table are presented results for stocks of elements in dead wood in both mountains, Vitusha and Staroplanina, in different fractions, standing wood, stumps and plank wood. We found that when comparing the values of the amount of elements, we found that Staroplanina had a larger stock of elements than Vitusha due to a larger amount of dead wood. Dead wood of both mountains is a major reservoir of carbon stored mainly in lying dead wood. All microelements such as manganese, iron, zinc, sodium, copper and lead have reserves below a kilogram per hectare, with the exception of manganese, which amount in Staroplanina was about 1.4 kilograms per hectare. As a conclusion, we can say that the order of study elements in dead wood was the same such as in the litterfall: carbon, hydrogen, nitrogen, calcium, magnesium, potassium, phosphorus, manganese, iron, zinc, sodium, lead and copper. Comparing the amount of elements stored in dead wood, Staroplanina had greater stocks than Vitusha due to the greater amount of dead wood. All other elements contained were several times less amount as stocks. The dead wood on both mountains was a major reservoir of carbon stored mainly in lying dead wood. Other authors were found the same, especially in lowland sampling plots. The average hydrogen stock was 125 kilograms per hectare for Vitusha and 805 kilograms per hectare for Staroplanina respectively. For nitrogen reserves, we found 23 and 99 kilograms per hectare for both mountains. The average calcium stocks were 9 kilograms per hectare for Vitusha and 22 kilograms per hectare for Staroplanina respectively. Magnesium stock in both mountains were almost the same. And this is only exclusion for Vitusha. It was slightly higher, this element, 3.4 kilograms per hectare, than for Staroplanina, 3.3. That maybe is due to the different decay classes, that mean different degrees of decomposition of lying, standing, and biomass and stumps. The average stocks of phosphorus was 0.5 for Vitusha and 1.5 kilogram per hectare for Staroponina, and the entire stock of micronutrients such as manganese, iron, zinc, sodium, copper and lead was 2 kg per hectare Staroponina and 0.5 kg per hectare in Vitusha. That's all. Thank you for your attention. And this research was founded by this project I have